Everyone, can you hear me now?
Oh, yes, sir.
Yes, sir.
So, there are so far only, 5 of you. 1, 2, 3, 4, 5. Okay. Anyway, this session is now recorded, so we can start our discussion. So last meeting, we discussed the top level view of a computer. So it shows the different functions, top functional level of a computer. Let's show that again. It's in our Diggler site. There's a Diggler app already, right? We go to Google Play Store. There's an info. Wala pa namang Diggler. Maybe it's included here. Have you tried it? Have you tried this app? Info profile. I'm not sure if there's a Diggler embedded there.
Information lang sa mga offices and
Information.
faculty.
Okay, faculty. So wala pang
Wala
Diggler.
pang integration, sir.
Pero wala pang Diggler dito.
Yes po, sir.
Okay, hopefully na. So anyway, we discussed the functional view of a computer before, no? Last meeting. So top level view, functional view as in terms of control, data movement, data storage, and data processing. No? So here's the diagram presented. Now, as a computer, it has a central processing unit, a main memory, systems in interconnection. It's called a bus also. Input and output. That's a computer. So the structure of a CPU. A CPU has a set of registers. The most common of which is the accumulator, because it's being used by the arithmetic logic unit to store input and output. To store the one of the inputs and the immediate result of the arithmetic logic unit. The control unit generates the control signals that activates the necessary component depending on the instruction that is set. The other types of registers are address register, data register. You have instruction register, or sometimes called instruction pointer. Program counter or instruction pointer. Instruction register is like data register that stores instruction codes instead of values. Okay. So a control unit has a sequencer. It has a clock. Do you follow? So it has a clock. Usually the sequencer controls the execution of instructions, fetch and execution of instructions. It's divided into two phases. The sequence, the fetch and execute. Okay. Okay. Any questions so far? I'll give you the exercises later. And then the next part is about computer evolution and the different periods or generations of computers. Okay. Now this is very important. The evolution of computers is very important in computer architecture. Why is that? Because it simplifies the design process. Understand the analysis of the design process. If you're asked to define the architecture of the modern IBM PC, as it is now, it will take you many days, not just a day, to describe the architecture of the motherboard, the system, the functional composition, no? Like the data movement and the interconnection systems. That's very complicated. No? So, however, one way to understand the design and architecture of a computer system is to study its evolution. Do you follow? No? How it came to be. Like understanding how your Android cell phone came to be. No? So it helps us understand the structure by studying how things came to be. Because computers did not uh, immediately become what they are. No? They evolved into small compositions of design processes. No? So paunti-unti, konting design, konting you follow, no? So it will allow us to understand the simplest form, starting from the simplest form, no? And then to the more complex forms and to the present. No? Later we will study the architecture of memory, starting from the very simple structure, no? As designed by the original designers. Who invented the first computer? Anyone? You remember?
Si Babbage, sir.
Charles Babbage. Ang ano? Charles Babbage is very popular, no? When was that?
I forgot na, sir.
1873. Namatay si Di, no? 1800s, no? Charles Babbage, no? Of course, you forgot, no? 1877 yata siya namatay. Basta 1870s ito. Saan ito, no? Which university? Oxford University. 1791, 1871 siya namatay, no? So it's probably during 1800s, no? Kailan niya na-invento ito? Cambridge University. Oh no, galing siya sa Cambridge. Kasi Cambridge lang siya. Oxford pala is a medical, no? Nasa chemistry and medical sciences Oxford. Pero pag engineering, Cambridge. Okay? They are from London, no? Kasi wala pang US during the time, no? The US is there but it's not yet that good in education. So kailan na-invento ang it's called the analytical engine. The analytical engine by Charles Babbage. Okay. (1837). No? He was teaching. Charles Babbage is an inventor. No? Inventors during those days, no, what they do is propose a design and get a funding from somewhere else. No? Usually the funding comes from a private institution, a private individual, or the UK government, United Kingdom dati, no? From the UK government. Now, Charles Babbage proposed, no, the invention. His first invention was called the difference engine, which is used for computing polynomials. Huh? So, it did not succeed. So he made a second proposal, which was partially approved, but was not fully approved. He ran out of funding. No? So he partially implemented his second invention called the analytical engine in 1837. Ito yun, no? Ito yung first computer, no? It's known as the first computer, the analytical engine. Okay? Did you see that? Will you program a computer like this? You could cut a finger here, no? Because you see, there are so many gears, no? There's what is called ingress, egress, no? Ingress is for input, egress is for output. And the mill, this is the mill. And then at every computation, you do a crank. What are the different components of Charles Babbage engine? You know, Ito kasi, ano, 1822 pala, 1837, he designed the analytical engine. Okay, first, known to be the first mechanical general purpose computer. Father of contemporary computers. There are two important figures there during that time. No? Charles Babbage and Ada Lovelace. Diba? Si Ada Lovelace, 1844. He's an English mathematician. She was also connected to Cambridge University. No? In fact, they were closely communicating with each other. Now, by that time also, an American inventor from the US invented a punch card system, a recording system. No? His name was Herman Hollerith. He invented the punch card. Okay. How he invented it, we will find out. No? So ito yung, it started during the modern period. It's called the modern period because the period before it was the Dark Ages. No? Modern period in world's history. No? This was the time when there were already steam engines. No? Balo kaka-invento lang ng mga steam engines, meron ng trains, no? And so on and so forth. Okay. So modern period na electricity is just beginning, no? Meron ng kuryente. Telephone, not yet there, no? Early 1900s, 18th century. Now, if you would like to study the evolution, let's look at the analytical engine. Okay. Okay. During that time, by the way, before we proceed, sino si Ada Lovelace? Who is Ada Lovelace? Countess of Lovelace, Ada Augusta Byron. Byron, Ada Augusta Lovelace. Augusta Ada King, no? Countess of Lovelace. He is also known as Countess Lovelace, or a Byron is a child of a baron. No? Hindi siya white. No? English mathematician and writer. But what is she known for? Who do you recall Ada Lovelace to be? Anyone? O +1 into the final grade if you remember. If you don't, okay. Anyone?
Sir,
Yes.
siya yung first computer programmer, technically.
Sino ito? Sino ito?
Si Dabon.
Dabon, okay. Yeah, I remember you, no? Dabon. First computer programmer, no? How did she program? I'll give you a bonus. No? How did she program, anyone? Anong pinogram niya? Di-program niya yung analytical engine, di ba? Okay. Bernoulli numbers. Generation of Bernoulli numbers, no? Ito yung kanyang Bernoulli program. What was the language before? Mathematical lang. Mathematics is the language of everything. Ito yung binary Bernoulli series. It's like a series of it's not random numbers, but it's a series of numbers, no? The first Bernoulli number is 1. Gauss ito, no? Bernoulli series. I-ano na lang natin. I-wiki na lang. How do they program during those times? Engineering was the main science, no? people were interested in making large and tall buildings, no? War machines. So engineering was the technology, was at the peak of technology during the time. So, for example, the train, the steam engine. No? This is the program. Oh. Do you follow? When you write a program, you will have a number of operation, one to n. Okay. The nature of operation, you will have the command. Okay. The variables used by the operations, and this is the data. No, the data is the memory. You will have to detail what is inside the memory of the computer. Okay. So this is the operation, variables acted upon. Okay, variable 1, variable 2, variable 3, variable 4. What is variable 1? You will have to define what variable 1 is. No? Do you follow? So this is the statement of the results. No? Okay. So ganun sila mag-program. No? Do you follow? You have to show. In fact, we are going to demonstrate this in Excel. No? And then you have the resulting variables. No? So you have variable 1, variable 2, variable 3, variable 21, 22, up to variable n. Okay? So mathematics was the main language. Okay? This is the Bernoulli series. What's the first Bernoulli number? Okay? Ito yung the first Bernoulli number is 1. The second Bernoulli number is 1/2. The third is 1.16. Okay? There's a formula to do. Okay? There's a formula to do this, and Ada Lovelace programmed that into this formula. Ito yung program niya to generate the Bernoulli series. Give a value of n, it will give you the nth binary, or rather Bernoulli number. No? Strange, no? What's the use? It has a use in mathematics, no? But for us, it's useless. But anyway, she demonstrated, the very important part there was, she demonstrated that the invention of Charles Babbage is not just an ordinary machine. It's programmable according to any purpose that you like. In fact, okay, we can demonstrate that certain applications in mathematics can be run on the analytical engine. Okay? Ito yung main components ng analytical engine. Usually, when you run a program, you have a formula and the data. Okay? The formula and data are provided by punch cards. Wala pang punch cards during the time. They were using Jacquard's looms. Okay? Have you seen a Jacquard loom? It's a machine that is used to weave fabric design. Ibig sabihin, kung mag-design ka ng blanket or ng curtain, no? Wall curtain, may design, di ba? Okay? You're going to use a punch card in order to stitch the design according to how the author would like it to be. No? Okay? So, merong Jacquard's looms. Now, sa Jacquard's looms, the value is read by putting in the numbers. Okay? Andali lang ha. Andali lang. Okay. So anyway, each card has a particular design, and the particular design is used to stitch, no, fabric into what it's supposed to become, whether a blanket or a wall curtain. Okay, do you follow? So there's a Jacquard loom. Which gave way, by the way, which gave way to the invention of the punch card. Okay, there's the Jacquard loom, no? Let's explain this. No? Ano lang talaga. I haven't muted my cell phone. No? So anyway. So ito yung ano, these are the cards in the punch card. Dali lang. Asan yung cards, no? Ito, did you see this, no? Di ba may mga cards dito? Sorry. There are cards on the side. Okay, they're sent individually to the machine. Okay, which the cards have designated holes. No, kung saan dadaan yung looms, they are called looms. They will pass through the holes of the cards, and the process of passing looms to the holes of the cards will create a particular fabric design. Do you follow? So now these cards are sent sequentially in a conveyor line ito, no? Papasok ito sila, iikot ito, no? Isa-isa papunta dito sa loom such that the output will be a fabric at the bottom. It's either a blanket or a wall curtain. Okay? May papasok. No. That's what it produces. Now, Herman Hollerith discovered that this can also be used as a storage device in a computer where you will have punch cards that stores characters. ASCII and IBCDIC, ASCII characters can be stored in a punch card. And they will be scanned sequentially in a conveyor line such that they can be read from one card to another. So one card can store one operation. Okay, so a program is a deck of cards which are read sequentially and executed by the analytical engine. Okay, so medyo mahirap, no? Now, so that's the punch cards are read sequentially through a Jacquard loom, which was originally designed for creating fabric. And then there's called a store, a memory capable of holding 1,000 numbers of 40 decimal digits. Okay, which means that kung tingnan mo yung yung program ni Ada Lovelace, no? If you look at the program, the variables V1 to V12 are actually in the store. Do you follow? Ito yung store. Okay? Ito yung mill. Do you follow? So, the Jacquard loom, dito yung mill, the Jacquard loom store these cards. No? Itong mga operation cards are from the Jacquard loom. They come in sequence. No? They are arranged sequentially. The first card, second card, third card, and they are read and fetched into the store. Okay? So parang computer talaga siya. It's really a working mechanical computer. And the mill, no? The mill is the arithmetic unit, no? Would be capable to perform all arithmetic operations, no? Plus comparisons sequentially, optional square roots even, no? Okay. Like the central processing unit in a modern computer, the mill would rely upon its internal procedures to carry out some complex instruction that the user's program might specify. Okay. Any questions so far? How do you program the analytical engine? Okay, so this is the mill, no? This is the mill. Now let's look at the picture. Ito yung mill. Do you follow? So, sorry, no? Ito. This is the mill. Let me just set them side by side. So, the mill is a set of wheels, rotating wheels. Each wheel is numbered sequence. It's like an odometer in a car. You follow? Where each wheel has numbers 0 to 9. You follow? So dito, in this example, this is a simplified version of the engine where the wheel can store 20 digits, but the actual design was 40 digits. Do you follow? No? Ito yung actual design niya. Isang gulong, isang wheel nito, 1 digit from 0 to 9. Now, this is a simpler version which was implemented by Charles Babbage, which can only contain 20 wheels. Anyway, masyadong malaki na yung 40 wheels, no? Okay? Do you follow? So ito, it has an ingress axis. Axis 1, axis 2, and egress axis. Okay. Axis are wheels. Do you follow? Okay, so ito yon. Ito yon. Ito yung ingress axis 1. Ano, it may be this, no? Ingress axis 1, ingress axis 2, egress axis. Okay, and there's a prime egress axis at the last. No? There's a prime ingress axis at the bottom, at the first. No? May mga rotating wheels. Okay. Okay. So the operations come in the card, no? Ano na si Mike Espera? Okay, and they are read individually, sequentially to the mill. Okay. So i-arrange siya. I-arrange yung cards. The card store basic operations, no? They're basically three types of cards: operation cards, number cards, and variable cards. Okay. An operation card is a card that contains a command, whether to plus, minus, times, divide, no? Modulo. A number card stores a number, a constant value. Okay. And a variable card stores a transfer operation, no? Used to transfer from the store to the mill or from the mill to the store. Okay. There's a special variable card which is used in case the store is full, okay, and needs a special variable. No? So how do they look like? Operation cards require only 4 holes. Okay, plus, minus, times. They identify the location of the holes, identify the location. The number cards require 50 columns of 10 possible numbers. So 50 columns, each card can store 10 possible numbers, each 50 columns each. No? 50-digit decimal numeral, pero 40 lang yung original design niya, no? Okay. And variable cards, okay, contain either a number that should be read from the store, or read from the store and or erased from the variable card, no? It's a transfer, no? Transfer kasi ito, no? So it stores a number to be transferred to the store or to be read from the transferred into the store or to be read from the store, no? So for example, here's an example numeric card, N001. Okay, this number represents a number card. Okay. Okay, it stores a value. S001, the S command is a variable card to store a value to the egress axis. N001 actually store a value to the store, no? A particular number, no? To the store. CF and CB are count forward or count backwards. Okay, you can move because you have a counter. To count forward means move to the next instruction. Count backward means go back to the previous instruction. Okay. Okay. Here's an example. N001. N is a number card. 500. Puts 500 in the store in address 001 of the store. N002 30 puts an address about the decimal value of 30 to the address 002 in the store. Divide is an operation card, which means it's going to divide. L is a variable card. It means load. S is a variable card, which means store. No? You follow? When you say L001, we load the number 001 to the ingress axis 1. And ingress axis 1 is the accumulator. Okay, L002. Now, the first load goes to the ingress axis 1, the second load goes to ingress axis 2. Okay? You follow? Ganun yung sequence niya. S003, store the primary result in the prime ingress axis. Ito yung may prime, no? Pero kung walang prime, stores the remainder of the... Actually, when you say S, you store the ingress axis to the memory. B is bell, H is halt. Okay. So we'll have an example program briefly. Hindi na natin discuss ang example program. Basta, do you want us to go through this? Medyo matagal, no? Okay. I'll have a sample program na lang. No? I'll show you a sample program in Excel. Okay, so you get to see this. Okay. Compute the nth factorial. Ito. Hindi lang yan the factorial program na. Factorial. Fourth factorial. Ito looping ito, no? Yung hindi lang loop. Without looping para mabilis, no? Loop pa rin ito. Ito sa CB. We'll use a sample program na lang in the net. This computes the fourth factorial. Okay. Let's use an Excel. Ito, without loop. Can you see that now? This is the same program which I've altered a bit. Pareho lang, no? Actually, pareho lang. You follow? Okay. Ingress axis, what are actually registers? Ingress and egress are actually registers. No? Tatlong registers lang. Okay. Ingress means input. Egress means output. Okay. This computes the fourth factorial. No? When you say N004, N004, this is variable 1. No? According to ano, this is variable, no, variable 0, variable 1, variable 2, variable 3. That's why if you look at the program of Ada Lovelace, meron siyang B1, B2, B3. Actually, this is the stored. Okay? Actually, it should also start with 0. Pero baka hindi niya ginamit yung 0 na. No? Di follow? So, ganito din yung sa atin. Okay. Do you follow? So, ito yung variables hanggang 1,000 by Ada Lovelace. Now, the operation here is written, more specific yung operation niya, no? And in our case, we will look at ingress and egress access 1. Egress means the output, okay? Let's follow this. N004, which means that variable 0 will store 4. N0011, variable 1 will store 1. Okay? N002, 1 will store 1. Ito. Okay? And the particular usage are explained here. Variable 0 is the next multiplier. Variable 1 is the decrement. Variable 2 is the partial product. By the way, what's the fourth factorial? Fourth factorial is 4 times 3 times 2 times 1. Okay, fifth factorial is 5 times 4 times 3 times 2 times 1. Okay, the product of the first n numbers. So times, the next card here is the variable card, times. Okay, followed by an L002 and L0000. L002 will store the ingress 002 to the ingress axis. Now 002 here is 1. So store siya dito sa ingress axis because it's being the first. The second is L000, which means that the ingress axis 2 will be stored from variable 400, which is this, which is 4. Okay. And then they will do a multiply. Okay. Okay. And right after the multiplication, the result is stored in the egress axis. Okay, 4. So ito yung 4. Okay. Why is this 4? Because it's 4 times 1. And we'll say S002, the egress axis, which is 4, is stored in variable 2. Okay? So nagiging 4 ito. So you see the program now? And then we minus. We minus because the next partial product, the next multiplier is 3. Okay? So we minus. First, we load L00. L00 is, what's the value of L00? 4. I'm sorry, no? 4 ito, no? 4. So, L00. And we load L001 to the ingress axis 2. So, this is 1. Okay, and then we subtract because this is a minus. So, the ingress axis will have 3. And then when you say S000, the value of egress axis 3 will be stored to 0. So, this becomes 3. Do you follow? Huh? So times. In other words, this is a loop which will first multiply 4 times 3. And then it becomes 12, right? And 12 times 3 becomes 24. Okay? And 24 times 1 is finally 24. Do you follow? So this is the same program that you see here. So, okay? So you have n numeric cards which start with n. You have variable cards which either S or L, and you have number cards which stores a number n. Okay? Egress. So kaya ganito yung that's why this is the program by Ada Lovelace on the analytical engine. Okay? Any questions so far? No? Now, after that, what happened? Anong nangyari after the analytical engine? The analytical engine was invented in 1837. Tama ba? 1837. So 1837, no? Walang nangyari after that. So in terms of computing and computer architecture, nothing happened since 1837. Because when Ada Lovelace died, she died young, no? Pagkamatay ni Ada Lovelace, nobody paid interest into the work of Charles Babbage. For them, it's useless to write programs on such a machine. Okay? So it laid to rest. However, no, during the night before World War II, 1935 to 1936, no, uh, okay. 1936, ito yung period nila Alan Turing, and then John von Neumann, and then Moseley and Eckert. No? Do you follow? No? Before World War II, analytical engine ito. Let's go to our main source. Dito sa 1943, before World War II. No? During the World War, no? J. Presper Eckert and John Moseley from University of Pennsylvania. This is Moore School of Engineering, Penn State University, no? Invented a computer, an electronic version of Charles Babbage analytical engine. It's called the Electronic Numerical Integrator and Computer, or ENIAC. Okay. It was used for computing. It was designed for World War II, no? But it was finished in 1946 and was used until 1955. Okay. So ito yung ENIAC. Basically, it's a decimal computer, like the analytical engine. Do you follow? And it has 10 accumulators of 10 digits. That's one of the main difference between Charles Babbage's design and ENIAC. ENIAC was designed by J. Presper Eckert and John Moseley. Moore School. Instead of using individual ingress and egress, they use accumulators, no? Which means that they can both be used for input and output. Unlike Charles Babbage's analytical engine, the ingress axis are used for input. The egress axis is used for output. However, there was no input device for the ENIAC. Hindi siya gumagamit ng input device. They have to be programmed manually by switches. No? Unlike Charles Babbage's design, no? The input device comes from a Jacquard loom. Okay? So manual programming by switches. It is composed of 18,000 vacuum tubes, 30 tons, 50,000 square foot. And it was programmed by women. No? Do you follow? Okay, by 1946, katapos ng ENIAC, John von Neumann invented the stored program concept. This is a milestone in computing history and computer architecture. No? Very important. 1946 nag-start, completed in 1952. However, no, there's an issue here because the stored program, the first stored program concept computer was EDVAC. Okay. Halos natapos lang sila. They finished almost at the same time in 1952. Si von Neumann pala is a professor of engineering in Princeton College, no? Advanced Science, Advanced Studies. Si Presper and Eckert are professors in engineering in Moore School of Penn State, no? University of Pennsylvania. Si ano is a mathematician, no? From Princeton College. They've worked together informally, no? EDVAC is a predecessor of ENIAC. Do you follow? The main difference between EDVAC and ENIAC is EDVAC is binary. ENIAC is decimal. Okay. But during 1946, when EDVAC was first invented, hindi pa siya tapos, no? It was started. Jan van Neumann released a design on EDVAC, but Jan van Neumann was not listed as one of the authors of EDVAC. Okay, but it was found out later that he was the original author of the design of EDVAC. He was a contributor to EDVAC. And the main reason why the stored program concept was recognized to be van Neumann's invention was because of his report on the design of EDVAC. Okay? Okay, during 1946. Siya nag-ano. Pero during that time, there was a misunderstanding. Parang hindi sila nagkaintindihan ni Mauchly and Eckert. He was put out of the project, so he invented his own version of the stored program concept and called it the Institute of Advanced Studies, IAS Computer, which was completed in 1952, also the same year that EDVAC was completed. Okay. So what's the main difference? It's called the stored program concept, no? Bucket stored program. Anyone? Nung oras tayo matatapos? Tapusin lang natin itong stored program concept, no? So 1947, UNIVAC 1, used for 1950s, UNIVAC 2. Hindi na na-mention dito ni yung EDVAC because there's a controversy in EDVAC. Kung sino talaga yung author. Okay? Hindi na na-mention ni Stallings in EDVAC. Okay, but it was also a stored program concept computer. Okay. Okay. Can anyone explain me about the stored program? What's the main difference? Because computers during that time, remember, the input devices used are punch cards. Do you follow? Punch cards. Right after, invented by Herman Hollerith, later IBM, no? Si Herman Hollerith nag-invento ng punch cards. After the Jacquard's loom. Do you follow? It's not very original, but it was a novel invention because instead of using manual looms, electronic na yung punch cards. Okay? Let's have the punch cards by IBM. Instead of using looms, it uses magnetic devices. IBM 100, this is the punch card reader and writer. Ito yung punch card, oh. Ganito. So 80 columns ito. Instead of the original design, which is 50 columns, no, by Charles Babbage. So 80 columns ito. Each punch card can contain 80 columns, which means one column means one number, one instruction. Okay, it's either an operation card or a value. Okay. Reader and writer. No? So ito. That's how it looks. No? Ito yung ilalagyan ng deck of cards. Ilalagay mo yung deck of cards yan, babasahin niya sequentially. Do you follow? So the deck of cards contain the program as patterned after the design of Charles Babbage. Do you follow? Following the design of Charles Babbage. No? So ito yung punch card na nakalagay doon sa deck. Okay? So there are 80 columns here. No? 1, 2, 3, 4. So which means that it can store an 80-bit binary number. Okay. By the way, IAS, the main difference between EDVAC and ENIAC is EDVAC is binary. ENIAC is decimal. Kasi decimal ngayon kay Charles Babbage. So they have reinvented this. And reconfigure this to be binary. Who invented the first binary computer? Anyone? ENIAC was known to be the first electronic computer, no? But it's decimal. The first binary computer, binary machine is not considered binary, but the first implementation of the binary system on an electronic device was by John von Vincent Atanasoff. Atanasoff Berry computer. I think it's 1937. No? Sila yung unang naka-invent ng binary numbers according to the suggestion of Ada Lovelace. Kasi Ada Lovelace suggested to Charles Babbage to use this binary numbers instead of decimal numbers. Do you follow? No? So that's the evolution there. Hindi naman talaga sila ang original. Ang original yan si Ada Lovelace, who suggested to Charles Babbage to change the engine and use binary numbers because Ada Lovelace was a binary mathematician. Okay? So si Atanasoff nag-invento ng binary numbers on electronic machines. Okay? And then they were adopted on EDVAC by Presper, Eckert, and Mockley. Mockley and Eckert. So ang naglalaban doon are Princeton College and Moore School of Engineering, Penn State. Sila yung and IBM. And rather Harvard University, who's conniving with or collaborating with IBM during that time. Okay, so ang Penn State later became and associated with DEC. Ang IBM nagiging Harvard. Okay, kasi university and manufacturers yung collaboration then. So ito ngayon yung punch cards. Let's go back. What's the store program concept all about? Can anyone explain to me? Can you plus na yun sa final grade? If you can explain the store program concept. +1 sa final grade. Anyone? Explain the store program concept. Wala eh, +1. Kaya nga +1. What's the problem with punch cards?
Mababa, sir.
Ha?
Okay.
Mabagal masyado yung punch cards. Diba? Mabagal talaga mag-read. If you are going to run a program, each command, each card can have several commands. Like in this case, how many commands? 1, 2, 3, 4, 5, 6, 7, 8, 9 commands. Basahin yan. Isang command na sa isang line doon sa punch card. Diba? So if you have a 1,000 command program, tapos sa isang card, 10 commands, you'll have 100 cards. Dalawa, may kanang echo gani. It's because you have two devices. You may have Zoom in one in your cell phone and Zoom in your You have to deactivate the Zoom in the other, the audio. Okay? Ganun ang problema sa Zoom pag you have Zoom in two devices, one of them should not have audio. Okay? So ganun, no? If you have a 1,000 line program, you will have 100 cards. And reading the cards is reading magnetically. So mabagal ito. Right? Do you follow? So if you are going to run a program with 100 commands, basahin to isa-isa. Load. Okay? So according to Charles Babbage design. Kasi ganito nga yung design ni Charles Babbage, di ba? Ganito yung design ni Charles Babbage. The program is on the cards. They're going to be read individually and transferred to the mill. Then go to the next command, transfer to the mill. Itong mga cards, these commands are in the cards. Right? They follow the same way as this. So ito
Yes, sir.
nandito sa deck of cards. Tapos ilipat sa processor. Ilipat sa CPU, execute. Do you follow? So, are you familiar with fetch and execute? Di ba? How is an instruction executed? Fetch and execute. First, it's fetched from the source and executed by the CPU. So, according to Charles Babbage, no, it will be fetched from the card and then processed in the mill. In modern lingo, it will be fetched from the card and executed by the CPU. And that should be very slow. Diba? You can imagine that it should be very slow. If you are going to compute a fourth factorial program, your fourth factorial program will not finish in a minute. Do you follow?
Yes, sir.
It's going to read individual cards. So what's the suggestion of Von Neumann? Anyone?
I-store ang program sa memory, sir.
How? So ang sabi niya, hindi na lang natin ito isa-isahin. What we are going to do is, we are going to store the program to memory as a batch. Store natin whole program, which means we are going to read it from the punch card, but we are not going to execute it. Do you follow? Kasi sa design ni Charles Babbage, read the card, execute. Read the card, execute. Read the card, execute. Ayaw ni Charles, ayaw ni Von Neumann yun. Ang gusto niya, we load all the cards one time. Okay? Into memory and execute them one by one from memory. Do you follow? Do you follow?
Yes, sir.
Yan ang tinatawag. That is what is called stored program concept. All computers nowadays are stored program computers. Diba? Even if you have a program in the hard disk, an executable file, it will not execute from the hard disk. Right? It will first load into memory and execute it one by one. No? Do you follow? Do you follow? So, what's the impact on the programming side? The stored program concept. Ngayon, when you're writing programs, your command and your data will be on the same memory. Diba? Unlike doon sa kay Charles Babbage, if you look at Charles Babbage design, ang command nandito sa Jacquard's Loom. Ang data nandito sa store or the variables. Right? They're two separate medium. Do you follow? Ang data nasa store or variables, ang command, the operation is in the Jacquard's Loom or in the card deck of cards. No? Now, in the stored program concept, both of them combined na ito in memory, which means the memory can contain both, either an instruction or data. Do you follow? Which makes the programming harder. Why? Kasi you have to distinguish what's in memory. Is it command or is it data? Do you follow? Which makes the design of the CPU harder, more difficult. But it makes the programming easier. By the way, baliktad, no? It makes the programming easier and the CPU design harder. Okay. IAS factorial. So ganito na ngayon yung program ng factorial law. Do you follow? So load. Ang load ganito na. And then this is we now have a linear memory. Okay, this is memory number 1, memory number 2, 3, 4. Memories 1, 2, 3, 4 contain data. Memory 5, 6, 7, 8 contain instructions. Do you follow? Naghalo na yung dalawa doon ngayon. Unlike before, operations are on the on the deck of cards and variable is in memory. Dito memory both, no? Both data and memory. So ngayon meron tayong jump 5. You have to jump to 5 because 1, 2, 3, 4 are variables. 5 is the first command. First command. Okay? May problema yung yung design ni John Von Neumann. Kasi 40-bit instructions and 20-bit words ang design niya. Which means that 20-bit words, ibig sabihin the values can only be 20 bits. And no, the instruction can be 20 bits, but the values, the variables can be 40 bits. Do you follow? So that when the program stores value, it occupies 40 bits. But when the program stores an instruction, it occupies 20 bits. Magulo, di ba? So yung addressing scheme niya, merong left and right. Okay? So when an instruction is stored, there's a left instruction and there's a right instruction. So we have a 5L, we have a 5R. We have a 6L, we have a 5R. 7L, 7R. 8L, 8R. Do you follow? Bakit nagkaganito? Why? Evolution ito eh. We need to study why. We need to find out the reasons. Bakit nagkaganito? Bakit hindi na lang 1, 2, 3, 4, 5, 6, 7, 8 dire-diretso?
Para masigot more instructions.
Oh, yes. Why? Because memory during that time was like gold. Diba? It's like gold. It's very expensive. If you are going to store instructions, 20-bit instructions into 40-bit words, kasayang yung kalahati. Diba? Because only the first 20 bits will be stored. So sayang yung kalahati. So Von Neumann decided that we should use the right part to store the next instruction. Okay, so meron na tayong, ang problema nito, meron tayong jump to the left and jump to the right. Okay, so move to the left and move to the right. So when you say jump 11, 0 to 19, we go to address 11 left. 0 to 19. Pag 20 to 39, that's address 11 right. Okay? So, it defeated the process, the design. Eh, gusto natin simplify programming, kaya lang nahirap yung jump. Because you have to identify the jump to the left and jump to the right. But it already introduced the concept of the stored program computer. Do you follow? Do you follow? No? So meron na siya dito. Now, the first computers on IBM, yung mga IBM 701 to IBM 709, were the first program computers which are very much like the IAS. Right there and then, IBM already created stored program concept computers, manufactured them commercially, and sold them very expensively. That made them so rich, no, that they became the tech giant for more than 50 years, no, from 1960s until to the 1990s. Tech giant yung IBM, they're bigger, much bigger than Microsoft, because they were selling stored program concept computers. Okay, do you follow? Now, one of the this is the first generation of computers, no, the stored 1946, yung mga IAS, EDVAC, no, IBM 701, these are the first generation. No, kasi kung mechanical computers yung first generation, second generation na ito sila, no. Basta the third generation came in the 1950s, no? Pagdating ng DEC. Do you follow? What did DEC do? Pareho lang ginawa ng DEC. IAS pa rin. Do you follow? But it manufactured smaller computers. Which means that Hindi siya 40-bit, 20-bit lang siya. Do you follow? 20-bit machines. But it's still basically like the IAS. But being a pure 20-bit machine, it means that both data and instruction are 20 bits. Do you follow? Both instruction and data are 20 bits. So what's the impact of a smaller computer with a uniform data size? What do you mean by uniform size? Both instruction and data are of the same size. Meron yata akong sample program dito, PDP-1 ito. Yung factorial program ng ano. Tingnan natin. This is the same factorial program. Okay, from the IAS, from the analytical engine to the IAS to the DEC PDP-1. Do you follow? So binago lang niya yung ano, ang LAC means load accumulator. Ang jump doon sa IAS dito JMP. Ang sub is still sub. And store is DAC, deposit accumulator. Do you follow? Load accumulator is LAC, load accumulator. So pareho lang, di ba? So they're trying to change the vocabulary. Skip if zero accumulator. Jump. Now there's the impact of the uniform size. It simplified the programming because there's because data, since data and instructions are the same size, they will have the same address. Do you follow? So there's no more that jump to the left or jump to the right. Okay? Do you follow? When you say jump 4, it goes to jump 4, which first loads. Okay? When you say jump 7, it goes to address 7. When you say jump 15, it's a recursive loop. Do you follow? This is DEC PDP-1. 1960s na ito. DEC became the next tech giant. They competed. They sold millions, no? Millions, hundreds of millions in dollars. No? They were not as big as IBM, but they got a very big share in the computer market. Ang dami nilang nabenta. They sold thousands of computers. IBM sold only maybe hundreds, but very expensive computers. Do you follow? What did they do? They simplified the IAS. Ang ginawa nila, 20-bit na lang lahat. Instead of 20-bit instruction and 40-bit data, 20-bit instructions and 20-bit data. Okay? Any questions so far? No? Let's go back to our slide. Patatapos na tayo, no? Ito yung ano, structure ni Von Neumann. So which means that the main memory is connected, contains the program loaded from the deck of cards. Okay, so the main memory contains programs from the deck of cards, and the central processing unit has a arithmetic logic unit and a program control unit. No, what it does is it fetches this time, instead of fetching the instruction from the deck of cards, it will fetch it from memory and execute, fetch and execute. Okay, so the fetch and execute cycles are done from memory, not from the deck of cards, which means that all programs, which assumes that all programs are in memory. Do you follow? No? Do you follow? Okay, so ito yung IAS, no? 1040-bit words. Ito yung kanyang ano. Ang problema sa kanya, in times of data, it stores 40 bits. But during instructions, it stores 20 bits. Kaya may left, right. These are the registers. The memory buffer register. The memory buffer register stores the data during operations. Not when you say mul 2. Mul 2, 2 is ano, by the way. Multiply 2, 2 is in the accumulator. No? The buffer register is like the egress axis. It stores the result and the data from memory during a load and store. Do you follow, no? Pag load and store, the buffer register stores what is going to be loaded and stores what's going to be written. Okay. The memory address register points to the particular address in memory that is going to be used during load and store, during lock and dock, no? Sa ano pa, PDP, DEC, PDP. The instruction register stores the instruction loaded during the fetch. No? Because there are two types of fetches, fetch a data or fetch instruction. When fetch data is done, the result is in the buffer. Do you follow? When fetch instruction is done, the result is in the instruction register. Meron din siyang instruction buffer register to do some sort of pipelining, read ahead. No? There's a program counter which produces the address of the next instruction, and then the traditional accumulator. No? There's the traditional accumulator from the ENIAC design, and the multiplier quotient which stores the result of division. Okay, so ito yung structure ng IAS. No? Do you follow? There is the arithmetic logic unit. The memory buffer register stores the data fetched from memory. Do you follow? The instruction register stores the instruction which is sent to the control unit and stores and generates the control signal. There's a program counter. Okay? The program counter generates the address of the next instruction to be executed. Do you follow? No. The memory address register also is an address register which generates the address to be fetched. Okay? To be fetched from main memory. Okay? Any questions so far? (1957), no? Yung PDP-1 first na produce. You look at the generations of computers, no? Next meeting. Kasi marami din itong details. Okay? There's something important that I seem to forget, no? About the DEC PDP, ano? So from 1953, no, 1952 natapos yung ano, yung EDVAC saka IAS. There's a question. By 1953, IBM produced the first 701, and they sold it in terms of millions. Millions ang pagkabenta nito, 4 o 5 lang ang nabenta. No? IBM 701. This is like the EDVAC or the IAS. Okay. And you may ask, how is IBM able to produce or manufacture computers using a technology that is not theirs? Ngayon, if you are going to produce a clone, you have to get a license, no? To clone a computer. Hindi naman pwedeng basta-basta mag-generate ng clones, no? You cannot just generate a copy of the Intel 701 or rather Intel Core i7. Hindi pwede yan. Di ba? You will be sued by Intel. And during 1953, how is IBM able to manufacture a computer whose design is not theirs? Anyone? Anyone? Or another +1?
I-purchase ang company, sir, behind sa punching cards.
They purchased the Hollerith card. Sila naka-merge sila, and they made, in fact, no, they associated with IBM associated with Eckert and Mokley, but they did not buy the patent for the stored program concept. Hindi nila nabili yung patent doon. Eckert and Mokley filed for a patent after 1953 for the stored program concept computer. Nag-file sila ng patent. But IBM was able to make, there's a controversy dito. Katulad ng Microsoft, di ba? Maraming controversy. Maraming controversy. Kasi later, during the 1960s, during the hindi nag-file ng patent si Eckert and Mauchly sa stored program computer. Do you follow? So which gave IBM the freedom to manufacture computers according to the stored program design and sell it for without paying royalties. Do you follow? Nagbenta sila ng stored program concept computer without paying royalties to Eckert and Mauchly or Von Neumann. They were free to do that. Why? Because Eckert and Mauchly did not file a patent for the stored program concept. Why did they not file? Kasi nag-file sila for a patent for ENIAC. But they were sued during the 1960s. It was later found out that the original concept of digital processing was not original in EDVAC. Sino ang original author? Who really is the original author of digital processing in electronic digital processing, yung digital compute, binary computers. Who's the original author? They pirated technology, which they did not contest. This was really brought to court, no? There's a story about this. And the court ruled out that Milwaukee court ruled out that the stored program concept cannot be awarded, or the patent to the first electronic computers cannot be awarded to Eckert and Mauchly. The stored program concept later was attributed to John Von Neumann. Pero si Von Neumann, wala ring patent ng stored program concept. Do you follow? Who's the original author? John Van Vincent Atanasoff, Milwaukee University. No? Siya ang nag-original na nag-invent ng digital numbers to be used in computers. It's called the ABC, Atanasoff-Berry computer, during 1936, before the Second World War. In 1946 na simulan yung EDVAC. Yung ENIAC is 1940s. No? It was later found out that Presper and Eckert paid a lot of visits to the John Atanasoff, no? John Vincent Atanasoff, and read the book. No? Binasa niya yung design ng Atanasoff-Berry computer and implemented digital processing on EDVAC. It was later found out that many of the concepts in EDVAC was patterned after the original invention of John Van Vincent Atanasoff. Do you follow? So that's the real controversy there. Eckert and Mauchly, it was a very popular, infamous, popular controversy during those times. No, only surpassed. Kung walang Kennedy assassination, this could have been the most popular news, no, at that time. This happened when Kennedy was assassinated. No? So nawala ito sa but this was the biggest controversy during that time. The invention of the first electronic computer in the US, no? By the way, the first electronic computer was invented outside the US. It's called Germany. Konrad Zuse. Okay, 1936 then was first invented by Konrad Zuse. In the US, the first binary electronic machine was attributed to John Vincent Atanasoff, okay, for the ABC computer. Many of the concepts of the binary computer was implemented in the EDVAC. The court ruled out that EDVAC is not an original design. Do you follow? No? So sino talaga nag-invento ng digital computer? Si Atanasoff. Okay? But the stored program concept is being attributed to John Von Neumann. Any questions? No? So next meeting, I'm going to start giving you exercises. Okay? Everyone? So si Espera nandito na talaga. Have you enrolled already?
Sa SOS, sir.
Oh. Nasa exist na siya? Wala pa. Are you enrolled already or late pa? Ikaw na lang kulang dito eh. Kasi Almerol. Pero si Almerol kay third year pa man to.
Eh, wala ko na-enroll, sir.
Wala ka na-enroll. Why? Ayaw mo?
Dahil, kalimot, wala wala lang.
Okay.
Lang sa ni, sir.
Ikaw, it's up to you. You can still enroll if you like, but it's okay for me. I don't have a problem. Baka pa may reklamo. You did not enroll for the second sem?
Nalayawan ka subject dito.
Ano na-enroll dali?
Integration, information. Siya selective for, dili kompleto ko ang
Ano man na, kuan ka sa sabit ka sa imong kuan? QPI?
or basta nakalimot. Ay, no, nakalimot siguro ko.
O i-add na lang. Nga si
Wala
kuan. Eh, graduating ka man, di ba?
Yes, sir.
Di ka ka-graduate.
I-notify na ako si Sir Bolang.
Ha? Ano
Yes,
siya?
sir. Yes, sir.
Sabagay, kung gusto mo graduate next year, kaya para dili na.
Okay.
Ha?
No, sir. I will graduate this year.
O sige. You process the enrollment, okay?
Yes, sir.
Okay, mag-question din ako niyan, why I allowed students to come class without having been formally informed. We are not allowed to do that, okay?
Okay, sir. Sorry.
Okay. So, see you next meeting, no? But you can still attend, no? You can still attend the lectures, okay?
Okay, thank you, sir.
Okay, sige. Thank you everyone, no?
Thank you, sir.
Okay.
And goodbye, sir.
Yes,
Bye,
sir.
sir.
Bye, sir.